NASA has said there is an invisible monster on the loose. It's a runaway black hole that has got a mass of about 20 million suns.
Among the most intriguing and enigmatic things in the known cosmos are black holes. They are a formidable force because they have the ability to warp space-time and an insatiable hunger for substance. For many years, researchers have been studying black holes, but until recently, they have unable to obtain any tangible data. The sharpest image of a black hole ever seen has now been made public by scientists. Come along as we explore the realm of black holes in greater detail and discover the significance of this picture, which has the potential to alter our understanding of them forever. But let's pause for a moment before we do that. Black holes weren't exactly simple to locate. Philosophers and scientists have been perplexed by the nature of the cosmos and the enigmatic forces that sustain it for ages. The discovery of black holes was a significant turning point in humanity's quest to learn the secrets of the cosmos, which dates back to ancient civilizations. Back in 1783, a sharp thinker made a daring forecast that set the whole thing in motion. John Michell, an English natural philosopher, proposed a theory that suggests there might be massively powerful, unseen objects in space that could be identified by observing a star's orbit. Following the publication of the theory of production in 1916, Albert Einstein's general theory of relativity established the foundation for contemporary theories of gravity and spacetime structure. According to Einstein's theory, large things have the potential to deform and twist spacetime around them. The Newtonian theory of gravity as a solely attractive force between objects was challenged by this groundbreaking idea. Numerous things, including the potential existence of black holes, were affected by Einstein's hypothesis of how objects behaved in the cosmos. It is believed that enormous stars that are nearing the end of their life collapse to generate black holes, which are extraordinarily large phenomena. Consider it this way: a star that runs out of fuel is unable to provide the necessary pressure to resist the pull of gravity inward. When a star reaches a sufficiently large mass, its core will simply collapse due to gravity, leaving behind a black hole in the place of the former star. Okay, so all of this makes sense now, but nobody was interested in considering the possibility of black holes in the past. For several years, black holes remained completely theoretical, despite the fact Einstein had already predicted their existence. Some scientists thought the concept was ludicrous, while others thought it was too fantastical to be true. In the 1970s, astronomers Paul Merton, Thomas Bolton, and Louise Webster made the observation that an unseen object was 6,000 light-years distant, circling a blue star. It turned out that the object, codenamed Cygnus X1, was the first black hole ever discovered. About 6,000 light-years away from Earth, in the constellation Cygnus, lies a binary star system known as Cygnus X1. A large blue supergiant star and a compact object, possibly a black hole, make up the system. Astronomers noticed that the system was producing X-rays in the late 1960s. X-rays are very powerful electromagnetic radiation waves that are usually connected to extreme cosmic phenomena like supernova explosions and the acceleration of mass onto black holes. The fact that the X-rays were coming from a nearby source that was completely invisible to optical telescopies Euro, meaning it was practically difficult to capture an image of one on camera Euro, rather than the blue star itself, perplexed the scientists researching Cygnus X1. Researchers speculated that material from the outer layers of the blue star may be being ingested by the black hole. Telescopes can detect the X-rays that are released as matter falls towards a black hole because they are extremely hot. That's what they began investigating instead. Cygnus X1's discovery was a significant advance in the hunt for black holes, as it offered verifiable proof of their existence and unlocked a completely new field of study. It also proved that contemporary astronomy is capable of delving into the greatest secrets of the cosmos and supported Einstein's theory of relativity. Although it is impossible to directly view black holes, their influence on the surrounding material may be noticed. For instance, a star orbiting a black hole experiences a Doppler shift in its light as a result of the star's increasing speed due to the black hole's gravity. The black hole's mass may be determined by measuring this shift. The detection of black holes can also be accomplished using gravitational lensing. The gravitational attraction of a black hole causes light from far-off objects to be bent and twist around it when it approaches. A distorted picture of the item may result from this phenomenon, which may be seen and utilized to verify if a black hole is there. There is still a great deal we don't know about black holes, despite the abundance of knowledge we have previously amassed. Even more absurd is the fact that they are present everywhere, not only in the universe's shadows. Supermassive black holes are found in the cores of at least 2 trillion galaxies in the visible universe, and there may be as many as 400 million of them in our own Milky Way. We had merely not noticed them, but they had always been there, everywhere. Similar to the bullies of the cosmos, black holes swallow everything whole and never let it go. For this reason, expanding our knowledge about black holes is crucial. Anything that steps too close will be engulfed, reduced to a single particle, and ultimately rendered insignificant. The fact that every black hole is different, with its own gravitational pull and set of laws, is what makes them all the more dangerous. It is possible for one black hole to behave exactly like another. A black hole is composed of 3 layers: the singularity, the inner and outer event horizons, and the outer layer. The point from which you can never return is known as the event horizon. It is the line encircling the black hole's mouth. In most cases, the moment something reaches the event horizon, it's finished. Similar to being stuck in quicksand, the more you try, the more you sink. However, in this instance, the quicksand is the black hole's gravity, and there is no way out. You will be drawn further into the black hole to the inner layer if, by some miracle, you are able to cross the event horizon. Inside a black hole, the known rules of physics do not hold true. There, it seems like a completely separate cosmos. Space and time are bent by the force of gravity, which is so great that everything is compacted to a single, tiny point known as the singularity. The black hole's singularity, where the majority of its mass is concentrated, is its core. It is a point with 0 volume and infinite density. Don't be fooled by this, though. Light cannot escape the singularity due to its intense gravitational force. Because they don't release any light, black holes get their name. As a result, they completely destroy anything they come into contact with. Although they have a frightening reputation, black holes are interesting objects. So how exactly do scientists investigate these celestial monsters? They investigate the radiation that black holes release as well as the gas and particles that surround them. It is comparable to analyzing an out-of-focus snapshot of a far-off item. There's a limit to how close you can get before your camera vanishes into thin air, something you definitely don't want. How then do scientists interpret all of this? Of course, they have a ton of hypotheses. To put it mildly, the answer to the issue of what lies beyond the event horizon that scientists have been posing may surprise you. What if there was a gate there, a portal to another universe, galaxy, or even dimension, rather than just nothingness? Now, this is no ordinary gate that we are discussing. We are discussing a technology that would enable us to travel faster than light, which is presently believed to be unachievable. However, if we could somehow develop the technology to do so, we could be able to travel into a black hole and come out into a whole different universe. Though it may sound absurd, it's not as unfeasible as it first appeared. According to certain hypotheses, the singularity at the center of a black hole might be a wormhole leading to another galaxy. Think of the possibilities. A black hole, a flaw in the matrix, may allow us to visit far-off stars and discover new worlds. Naturally, that's a long way from being a reality. Regarding black holes and the nature of space and time, there is still much that we do not know. It's astounding, though, that we're even thinking about the possibility of employing black holes as a shortcut for interplanetary travel. Furthermore, if this notion is true, it may completely alter the landscape of space exploration. Still, not all scientists believe that this is feasible. Some believe the solution is much more straightforward yet still somewhat complex. How about if black holes were just illusions? Tokyo-based scientist Enrico Rinaldi thinks just that. According to his holographic duality hypothesis, we should view black holes as holograms in order to fully comprehend them. This implies that we should investigate the external events around the singularity rather than the inside ones. Nevertheless, how is a black hole a hologram? Well, gravity and particles are the main players in this. Black holes function in the third dimension, according to Rinaldi and his colleagues, and their surroundings are a component of the equation. In fact, the gases and dust particles that whirl around a black hole provide details about its nature. Consider a black hole as a ring that is gradually devouring everything in its path rather than as a sink. It gets stronger and draws in more particles and gases as it takes in more and more stuff. This produces an energy vortex that spins and is visible for light years. What does this imply for our knowledge of black holes, then? It implies, among other things, that we should turn our attention from the singularity to the area surrounding it. We may learn more about black holes' capabilities and modes of operation by examining the patterns of gases and particles. However, this theory's consequences reach beyond black holes. Holographic duality has the power to alter our conception of the cosmos as a whole. It implies that what we perceive as real could actually be a hologram or projection of something else. Though it seems like something from a science fiction film, this is actually a possibility. This hypothesis states that our perception of three dimensions is really only a projection of a two-dimensional surface. Though it may appear counterintuitive, this idea is grounded in science. A well-known physics theory called the holographic principle postulates that data in one area of space may be represented by data on another area's surface. Stated otherwise, a space's content can be projected onto its edges, resulting in a structure like to a hologram. The holographic principle has the potential to completely transform our conception of the cosmos. It could imply that what we understand about the universe is really a projection, a shadow of something greater. However, what else might that be? According to some scientists, there could be several holographic projections reflecting distinct realities, and our world might just be one of them. This might imply that there are a vast number of parallel worlds, each marginally distinct from our own. Furthermore, if the theory that black holes are portals is correct, they could hold the secret to knowing everything. Hey, they are all still only speculations. The real understanding of things makes all the difference. For ages, scientists have conjectured about these unseen behemoths of space. We now have a breathtaking image of one at the heart of our own Milky Way galaxy, courtesy to the visionary work of the Event Horizon Telescope (EHT) group. The supermassive black hole at the center of our galaxy is called Sagittarius A star. Given the evidence of stars orbiting something unseen, compact, and incredibly massive, scientists have long hypothesized that this mysterious object was a black hole. However, the picture they took offers the first concrete proof of it. It's difficult to accept that what we're seeing is a black hole since the visual is so beautiful in and of itself. The black hole itself is absolutely dark, so we cannot see it, but its blazing environs show us its unmistakable signature, a dazzling ring-like structure around a dark center area. The black hole's tremendous gravity has actually twisted light into this ring. It is an astounding 4 million times more massive than our sun. That should help put the enormity of the situation we're in front of you into perspective. However, how do we manage to get this incredible picture of this unseen object? It wasn't simple, though. The black hole seems to be about the size of a donut on the moon since it is situated around 27,000 light-years from Earth. The Event Horizon Telescope team had to build a virtual telescope the size of the entire world in order to take a picture of it. 8 current radio observatories on Earth were connected by the Event Horizon Telescope to create a single virtual telescope the size of the Earth. Then, they observed Sagittarius A** for several nights, gathering data for several hours at a stretch much as when a camera has a long exposure period. The outcome is an amazing picture that offers compelling proof that the object in our galaxy's center is, in fact, a black hole. However, the image is much more than a nice picture. It represents a scientific discovery that has significantly advanced our knowledge of what occurs at the galactic core. In addition to providing fresh information about how these enormous black holes interact with their surrounds, the picture has validated a number of predictions made by Einstein under the general theory of relativity. However, a lot remains to be discovered about it. You see, while Sagittarius A** is the nearest black hole to Earth, it wasn't the first one that we were able to thoroughly examine. Even before Sagittarius A* was seen, research was being done on another black hole, M87. M87, sometimes referred to as Messier 87, is an elliptical galaxy found in the Virgo constellation. A black hole, the first black hole to be directly photographed in 2019, is located in its nucleus. However, M87 was already a subject of curiosity for scientists before we even noticed its shadow. The strong radio radiation that M87 emits is one of the things that makes it such an interesting item. In fact, among the hundreds of galaxy systems that make up the Virgo cluster, it is the most potent known source of radio radiation. This suggested that the galaxy may contain extremely hot gas, which was verified when M87 was discovered to be a potent X-ray source as well. However, M87 is special not just because of its energy but also because of the manner in which it emits it. A bright gaseous jet extends from the galactic center. Synchrotron radiation, a kind of non-thermal radiation emitted by charged particles accelerated in magnetic fields and traveling at almost light speeds, is emitted by this jet. We can learn a great deal about the black hole's surroundings and internal operations from this radiation. When the Event Horizon Telescope captured photos of the galaxy's core in 2017 that revealed an asymmetric ring of radio emission encircling a black object, M87 grabbed headlines. The image was the first concrete proof of a black hole's existence, and that dark object was the black hole's shadow. With a mass 6.5 billion times that of the Sun, the black hole at the heart of M87 is not your typical black hole. Because the black hole is revolving, there is a brighter area on one side of the ring of radio emission around its shadow. The Doppler effect increases the emission of material on the black hole's side that is rotating toward Earth, giving the material a brighter appearance. Electrons are propelled to almost the speed of light by the gravitational energy produced by gas spiraling down into the black hole. It is believed that the brilliant gaseous jet coming from M87 represents radiation from this electron beam. These jets, which may travel hundreds of thousands of light years, are some of the universe's brightest things. By heating up and releasing gas, they are believed to be essential in the development of galaxies, perhaps preventing more star formation. The black hole and surrounding disk of M87 have given scientists a once-in-a-lifetime chance to test Einstein's general theory of relativity, which describes how gravity behaves in the universe. That elevates things to a whole new level, especially when paired with what we've learned about Sagittarius A*. The scientific community now has a wealth of opportunities to further their understanding of black holes with the discovery of two of them and a clear photograph of one. The fact that we can really examine two of them implies that we can finally compare two real black holes, even though we can't go as near to M87 as we can to Sagittarius A*. This small information has the power to completely alter everything. Did you enjoy this video? Please like and comment below. Turn on the notification bell to get notifications for videos like this.